this computer. Okay, I'm not recording, guys. So we're gonna go as far as we can in the 30 minutes. And then I think we can finish it in 30 minutes, but we'll see. Let me get a calculator real quick. Hopefully you guys were able to find the assignment of where it was. I made a new module. And let me let these two people in. All right, question number 1. It says, write a linear combination of cosine and sine as a single cosine with a phase displacement. So that means that I want to see a single cosine with a phase displacement. So hopefully you remember something like y equals a cosine theta minus d. And that's what we're talking about here. So that 12 acts like a vector, like an x value. That 5 acts like a vector in the y direction. So it would be ideal if you did a little sketch, 12, 5, point. You don't have to do that sketch, but it would be ideal. And then this is a Pythagorean theorem, right? 12 squared plus 5 squared. 12 squared plus 5 squared. And you get 169, and then the square root of 169 is 13, and I didn't have to do all that. You could have probably just looked at it and it was a Pythagorean triplet, right? And then from there, so that's your amplitude, and I need this angle there. So that angle is just simply arctan 5 over 12, and you don't have to do arctan. You can do arc sine, arc cosine, it doesn't matter. So then in your calculator, if I am in radian mode, well, let's go ahead and put it in degree mode. So let me put my mode in degree. You know what? I'm in radian mode. I'm going to leave it. I'm going to say radian. And I'm going to go arctan 5 over 12. And I get 0.3947. 0.39479. So here is my equation. Y equals A. Y equals A. Y equals 13. Cosine theta minus 0.39479. This is rounded, or it might be truncated. Oh, it's round. It doesn't matter. And there it is. And I think we can all do that, right? Okay. If there's a question you guys want me to skip, let me know. This one says, express each equation as a linear combination of cosine and sine. So this theta is like an A, that 30 is like a B. Sometimes you won't have theta minus 30. Sometimes you'll have both that are going to be numbers or variables or something. So obviously it says cosine. So we're using cosine A minus B. And cosine A minus B is cosine A cosine B plus sine A sine B. And then from there, I'm just going to go ahead and rewrite this. Y equals 10 bracket. Here I am, guys. I'm going to use this. So I'm going to write cosine theta cosine 30 degrees plus sine theta sine 30 degrees. And then distribute the 10. So 10 cosine 30 degrees cosine theta plus 10 sine 30 degrees sine theta. And then just tell me what cosine and sine of 30 are. So 10 cosine of 30 is square root of 3 over 2. Plus 10 sine of 30 is a half. We won't penalize you if you round, but I would prefer a perfect answer, guys. So what's a perfect answer? 5 cosine theta. 5 square root of 3 cosine theta plus 5 sine theta.
Mr. Chavez?
Yes, ma'am.
Why do you move the cosine 30 next to the 10?
Oh, because cosine 30 is a number. So anything that is a number, I start moving it to the front.
Oh, okay.
Any other questions, guys, on that? So is it cool if I skip question 3, only because question 3 is exactly the same as question 2?
Yes.
So let's keep going. And so here we go. And now we have an application problem where it says solve algebraically cosine x cosine 0.6 minus sine x sine 0.6 equals 0.9. And what I'm hoping that I see is that you guys see that I can simplify that part. You see cosine, cosine, sine, sine, and I hope that you guys will realize, oh, that's just cosine A plus B. where A is X and B is 0.6. So you rewrite it, and you're going to go cosine of X plus 0.6 equals 0.9. And then once you have it to this way, once you have it in that format, now it's easy to do. You do need a calculator because that 0.9 is not a perfect coordinate. I don't want to see like a whole bunch of like, I just want to see just straight calculations, guys. Arc cosine, x plus 0.6 equals plus minus arc cosine of 0.9 plus 2 pi n. Move the 0.6 to the other side. So x equals negative 0.6 plus minus arc cosine of 0.9 plus 2 pi n. I would like to see the general equation. So x1, so what I mean by general, type that into the calculator. So I have my calculator right here. And usually if this were class, I would show you decimals, guys, but I'm just going to go ahead and type it in just so we can make this fast. Negative 0.6 plus arc cosine of 0.9. And let me know if I get something wrong here. This is in radian. So negative 0.1489,732 plus 2 pi n. And then x2, instead of plus, I'm going to do minus. And I take away that minus sign, plus sign, and put a minus. And I get negative 1.051027 plus 2 pi n. So if you remember in the notes or if you remember in the homeworks, I took away points. I might have taken away a point if I didn't see the general equation. I didn't take away that much points, 5 points maybe. So then from there, I just get all my answers, guys. So let's see, plus pi. Where are you, pi? Plus pi. So one answer is 2.0905 is coming from x2. And then another answer is coming from that negative 0.14. So let me scroll up and I'm going to push plus 2 pi. Oh yeah, plus, oh, I accidentally put minus there. Plus 2. Oh, and I got it wrong, huh? That 2.09 is not an answer, guys. 6.134212. The 2.09 is not an answer. I didn't add 2 pi to it. I added pi. See, so even I make mistakes. 5.2321. There we go. And keep going. I think that's it. I think those are the only two. And that's it. Cool, guys, or not cool? Awesome. So there it is. Pretty straightforward. Is it okay if we skip number 5? So number 5 is the same as number 4?
Yes.
Okay. So look at the next ones, guys. So it says find for the next two problems, transform the product into a sum or difference of sines or cosines with positive arguments. So what that means is I am looking for a way to get 2 sine 41 cosine 24 degrees. Hopefully you look at it and you're like, oh, sine cosine, the only one that does that is sine. So I'm going to write what sine A plus B is here. I guess A plus minus. So sine A cosine B plus minus cosine A sine B. If you want to just use your formula, I guess you can, but I recommend you just go right into it like this. Since this says 2 sine cosine, I want to actually see, like, I would prefer to see this. If you use the formula, that's fine, guys, but I would prefer to see this. So that 41 is A, that 24 is B. So I'm going to write sine 41 degrees plus 24 degrees is equal to sine 41 cosine 24 plus cosine 41 sine 24. And then on the bottom, right?
What do we do with that 2 at the front?
Oh, I don't do anything to it. That's what I want to get. I want to see if I can get a 2.
Oh, okay.
You know what I mean? 41 minus 24. You can use your formulas, miss. You don't have to do this, but I would prefer to see this. And then from here, this is what I want you yourself asking. What do I got to do to get that 2 in the front? Do I add them? Oh, I said that funny. Do I add them or do I subtract them? What do you think I should do?
Add them?
Yeah, you add them. If you add them, this will work. So sine of whatever 41 plus 24 is, plus sine of whatever 41 minus 24 is equal to 2 sine 41 cosine 24. And this is what I wanted. That's what I have there. So this must be my answer. So what's my answer? Sine of, let's see, what's 41 plus 24? 41, 51, 61, and then add another 4, so 65 degrees, plus sine, and then I'm going to subtract 24. 41, 31, 21, and then add, that's 17. There it is. Hopefully I didn't do anything wrong. And that's my answer, guys. That's what I wanted. I wanted a sum or difference. Sum or difference. And I have signs in this case. Does that make sense, guys? And yes, there are formulas. If you want to use your formulas, you can, but I don't bother memorizing. As long as you know the composite argument properties, you can always get them. So this is the same. The only difference is that you have a 3x and a 7.2. Yes, ma'am.
Can we do number 7 though? Because this is the one area I think in the review that I'm struggling a little bit. So can we go through number 7?
Yes. That 3x is an A, that 7.2 is a B. Since I have sine and sine, the only one that does sine is cosine. So I'm going to write cosine of 3x plus 7.2. And I'm going to write, let's see, cosine 3x, cosine 7.2, minus sine 3x, sine 7.2. And then on the bottom, I'm going to write the other one, cosine 3x minus 7.2. And then that becomes cosine 3x, cosine 7.2, plus sine 3x, sine 7.2. And then I do my little line here like so. And then you just ask yourself, what do I got to do to get 2 of them? And the only way to get 2 of those, sine, they're back here, is if I turn the top one into a negative and add them up. So I'm going to put a minus sign here on the top. And then that means that I'm going to change colors here. That means this one turns to a minus and this one turns to a plus. And if I add them up now, these go away. And I will have 2 of these. 2 sine 3x sine 7.2, which is what I wanted. That's what I wanted. So what did I do? I'm going to put the positive one first. I did cosine 3x minus 7.2 minus cosine 3x plus 7.2. And this is the answer. And there it is. I have a cosine in terms of difference, in terms of a difference for cosines. And that's it. Did that make sense, miss?
Oh yeah, I think I just need to do a bunch of those because that's the area where I'm still a little bit like I get stuck.
There's let me see, is there questions on this on UH? No. I'll see if I can do a practice delta math that doesn't, I've been saying that for a while, right? And I never did it. This week has just been crazy, guys. I can't even tell you how much paperwork we've done this week. I will create a delta today just so you guys can have practice. I'll look for these in particular. I don't even know if delta has
I think
these.
that's the reason I'm struggling on it is because like it's not on the UH, and so when I would practice like on the UH, it didn't come up, and so I then forgot how to do it.
Yeah, let me look on UH. Let me look on delta, and then I'll give you. I'll text you later on today. You have a soccer game today, right, or something?
Not till tomorrow.
Oh, okay.
So today is
so as soon as, because I have a meeting at 4:45, but as soon as I create it, I'll send you a text, or maybe I'll just send the group me a text. Yeah, I'll send the whole group me a text because I think everyone will benefit. So I'll create a practice one, and if I can find some, and I'll send the whole group me a text. All right, question 9. Should we do it? Question 9 or no? Yeah, okay. So notice I have sine 3x here, I have sine x here, and so that 3x is the same thing as 2x plus x, and you got to choose 2 numbers that are going to give you the same thing. That doesn't even make sense. 2 numbers that when I add them will give me 3x, and those same two numbers, when I subtract them, will give me that x. So in the past, if you look at your notes, I created a system of equation, and I told you to come to the side and do a plus b equals 3x, because I got to choose an argument for a and an argument for b. And then I told you to go a minus b is equal to x. I would always choose the summation to be the biggest number and the difference to be the smallest number. If you do it the opposite, it'll still work. It's just that you're just making life more complicated. So 2a equals 4x. The b's cancel out if you add them up. So that means a equals 2x. And as soon as you get one of them, you'll get the other one. So that means b has to equal x. So this one's simple enough that you probably don't even have to do that. But you can probably just recognize it. But if you don't, no big deal. Just put it on the side. And then just go sine, and then just write 2x plus x. And then expand what this one is. So this is sine 2x cosine x plus cosine 2x sine x. And then I'm going to write the other one right below it, 2x minus x sine 2x cosine x plus, nope, not a plus, minus cosine 2x sine x. And what am I doing? I am subtracting. So since I'm subtracting, this guy is going to be minus. Oh, let me change the color so we know what's up. That's going to be a minus, and this dude's going to be a plus, because negative times a negative is a positive. So these two dudes go away, and now you have 2 cosine 2x sine x. So what do I have? So I know that sine 3x minus sine x is going to equal this expression. And
Wait, I have a question. How do we know when to put it as negative? Or at least for this one.
What do you mean?
Like did you subtract or did you make that second equation negative?
I subtracted because there's a minus right here. So because there was a minus, I subtracted. So that means I'm doing this minus, and then I'm distributing the negative like that. So that minus that distributed, that turned the sine 2x cosine x into a negative, and that turned this one over here into a positive. Does that make sense?
Yes.
Okay.
Mr. Chavez?
Yes, ma'am.
From that, so I got to that point and then I set it equal to 0, but then for some reason, when I was setting it equal to 0, I wasn't sure whether I got the right things equal to 0. So could you go through that bit?
Yeah, we're not done yet, miss. Boom.
Okay.
No, I'm sorry, miss. I didn't mean to air punch you. So now, since that equals 0, oh, look, a small smiley face. Since that equals 0, I'm going to go ahead and just solve where this is true. So I'm going to do the sine x first because that's the easy one. So where is sine x equal to 0? Well, in the unit circle, sine x is 0 at 0, pi, and 2 pi. So x equals 0, pi, and 2 pi. And those are all legitimate answers. They're all within the 0, pi, and 2 pi there. So now I'm going to go to the cosine 2x. So this is some answers. So cosine 2x is equal to 0. So I'm going to do arc cosine 2x equals plus minus arc cosine of 0 plus 2 pi n. Let's see, where is cosine 0? Up here at pi over 2. So I'm going to write it over here. So 2x equals plus minus pi over 2 plus 2 pi n. Divide by 2, divide by 2, divide by 2. X equals plus minus pi over 4 plus pi n. So now that I know that I got pi over 4 plus pi n, plus minus pi over 4 for that matter. So I know it's all the pi over 4s. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. That's kind of fun, actually. So there it is. Chavez, how'd you do those so fast? Well, I'm adding pi, guys. They come in linear pairs when you add pi over 4 plus pi. So it's all the 4s there. So what are my solutions? If you want to put them in order. So, okay, all this, it goes to that one question. So I should have put more space here. X equals, I'm going to write them in order. Let's see, 0, comma, pi over 4, comma, then 3 pi over 4, comma, then pi, comma, then 5 pi over 4, comma, then 7 pi over 4, comma, then 2 pi. There it is in order. You don't have to give them to me in order. If you didn't, that's fine.
Okay, thank you. That makes a lot more sense.
All right. Question 10. Question 10, I actually have this one as a multiple choice. I'm not trying to offend anyone, but hopefully you guys will get these ones correct. That's an A, that's a B, that's an A, that's a B. So you see sine, cosine, cosine, sine, and hopefully no one gets tricked. That's a minus, so that means this is sine A minus B. The A was a 9x, so sine 9x minus 3x, and you just write sine of 6x. Cool.
Very cool. Yes.
Cool. And then here comes the big deal. I have 2 of these, I think, currently. I actually have 14 questions on the exam, and by no coincidence, there's actually 14 questions on this. So I don't know. Hopefully, I'm not making this review like look exactly the same as the exam. So I gotta go look at the formatting. But anyways, there's more multiple choice on the exam than on this one here. I don't know if that's a good thing or a bad thing. I got to see work for full credit on this one here. I don't want you to get lucky just by answering an answer, because you have a calculator. You can easily just tell the calculator, give me angle X, give me angle Y, do that, sine of that angle, and then choose the corresponding correct answer. Don't do that. I want to see the work. So sine of X plus Y is equal to sine X cosine Y plus cosine X sine Y. And then from there, guys, I need to see that you put correctly what sine X is, what cosine Y is, with the correct quadrant. I would like to see this. A lot of you guys, when you guys did the quiz, you did not give me the correct reference or the correct quadrant. You just drew triangles. And I think, which is fine. It's fine if you just draw triangles, but make sure you know where quadrant you're in, so you know what's positive, what's negative. So one way to never mess up is to just draw the grid. Exaggerate quadrant 1. There it is, quadrant 1. And I just draw a triangle like that. See, here's angle X. Sine is a half, so 1 over 2. So this has to be square root of 3. 2 squared is 4. 1 squared is 1. 4 minus 1 is 3. Or from the unit circle, square root of 3 over 2. If Y value is a half, the X coordinate has to be square root of 3 over 2. So there it is. And then I'm going to exaggerate quadrant 1 again for angle Y. So there's angle Y. Here's angle Y, not to scale. And it says sine Y is 3/10. So I put a 3 here, I put a 10 there. And then again, 10 squared is 100, 3 squared is 9. 100 minus 9 is 91, and just leave it as square root of 91. I can see already there's square root of 91s all over the place. So I must be in the right track. Then from there, you just plug and chug, guys. Sine X was given, it was a half. And then it says cosine Y was not given. I come back to my graph over here. Cosine Y is square root of 91 over 10. I put a plus. It says cosine X, I go to the X one, is square root of 3 over 2. And then in sine Y, I go back to the Y, that was the given one, 3/10. Make sure that the signs are correct. They are. Everything's in quadrant 1, so everything's positive. So then it just goes square root of 91 over 20 plus 3 square root of 3 over 20. I have the same denominator. So square root of 91 plus 3 square root of 3 over 20. We're still okay, guys? Okay, I think it helps to draw the reference triangles. If you don't draw the reference triangles, I'm not going to take away points. Just make sure you are drawing correct quadrants. So make sure you keep tap of that. I would prefer you do this, but yeah. So just, I might just make a note if you keep making errors, just draw your grid and you'll get them right all the time. So this one is similar to 11. So is it okay if I skip it, guys?
Yes.
Okay. So here we go. The last 2 questions. I think we're doing pretty good in time. So these are the questions that we I think we did plenty of these in Delta Math, but I don't know. Delta Math gave you easy ones. I think Delta Math just gave you all the acute ones. So it's possible that we have angles that are negative. So let's see. I have an easy one here. It wants me to find cosine 2a. So hopefully you remember there are several ways to get cosine 2a. Let me write all your general formulas. Let's see. We can do cosine squared of a minus sine squared of a. That's one way. You can do, let's see, what's the other way? 2 cosine squared A minus 1. I think that's correct. Let me know if I'm wrong, guys. I make mistakes all the time. And let's see, 1 minus 2 sine squared of A. I think that's correct, guys. Side note, cosine squared A plus sine squared A equals 1. So let's see, sine squared is 1 minus cosine. Distribute, boom, boom, positive. Yep, I think it's correct, guys. I think everything's legit. And let's see, I want cosine 2A. They give me cosine A. So maybe you opt to just use this one. Cosine 2A is equal to 2 parentheses. It says cosine A. Well, they give me cosine A. Negative 3/5, put a square on it, minus 1. This one doesn't matter. You don't care about the angle that you're in because this one doesn't have a plus minus. So this is just going to be 2 times 3 squared is 9. 5 squared is 25 minus 1. So let's see, double the 9. That's 18 over 25. And I'm going to turn that 1 into 25 over 25. And as you can see, you can do everything without a calculator, guys. 5, 6, 7. This is negative 7 over 25. Not once did we touch a calculator on this one. And yes, you can do this. It's not just me, guys. I'm not a calculator guru or a number guru. You guys can do the same. All right, let's do this part. That's the interesting one. So I'm going to do it in blue. So I'm going to circle it and color code it. So that
one, we don't have to figure out, because it's only one possible answer, we don't have to figure out whether it's positive or negative, because we don't have to multiply the 90 and 180 by 2 or whatever to figure out where it fits in the quadrants.
Correct. You're correct, miss. Sorry, you just reminded me of something. I'll show you a video later on. It's so funny. You reminded me of something that's really funny, and I hope you don't. I hope you don't get offended or rowdy by it. It's okay. Can I tell you? I guess there's this,
sure. I don't know.
this little kid, and he's on YouTube, and he's like, "Did you ever figure?" Yeah, it's really funny. Anyways, I promise you, it's a compliment. It's not. I'm not throwing shade. I promise.
Okay.
All right. So anyways, so here it is, guys. Yeah, you're right. I don't have to worry about positive or negative because the formula, there's nothing embedded in there that's positive or negative. Yes, a stuttering vine. Not that you were stuttering. Not that you were stuttering. I promise. Here we go.
I shouldn't. Okay, sorry, but now I'm going to begin.
No, you're good, miss. You're good. You're good. I promise you're good. Did you ever? Oh, that's funny. All right, here we go. So here's the angle, the formula for sine half A, and let's figure it out. So I know what cosine A is because they already gave it to me. So I'm going to write plus minus. Do I have enough space down here? Yeah, I do. Square root 1/2 parenthesis 1 minus a negative 3/5. So that minus is going to turn to a plus. So I'm going to write plus minus square root 1/2. And then that 1 I'm going to turn to 5 over 5. So then let's see. Let me see if I can fit it all in here. 1/2, 5 plus 3, 5, 6, 7, 8. That's 8. And then 2 goes into 8 4 times. So plus minus square root. And I'm going to have square root of 4 over 5. So plus minus square root of 4 over square root of 5 from the laws of exponents. The square root of 4 is 2. So plus minus 2 over square root of 5. If it's a response, you can leave it alone right there. If it's multiple choice, well, it is actually at the moment multiple choice. But if it's multiple choice, which it is at the moment, you might have to simplify that. So let's simplify it. Plus minus 2 square root of 5 over 5. So there it is. Now I got to choose whether it's positive or negative. So how do I choose whether it's positive or negative? I want half of A, not A. So I know that A is between 90 and 80. So I come here to the side and I go, A is between 90 and 80 and 180. And I don't remember if it equals or not. No, it doesn't. So what is half of A? Well, half of 90 is 45. And half of 180 is 90. And I should be technically correct here and put degree symbols. So because my half A is between 45 and 90 degrees, that's quadrant 1. And in quadrant 1, everything is positive. So it's a positive one.
So why did we do the 2a? Wait, how do we know that we're looking for the answer for the half a, for sine of half a, but we also did cosine 2a?
Oh, I asked for both. You can see right here it says cosine 2a and sine half a.
So because it's the answer we get for 2a.
The answer we got for 2a was negative. Everything for cosine 2a is in red, and everything for sine of half a is in blue. So the answer for cosine 2a is negative 7/25.
Okay.
Could you just explain again why the cosine of 2a is negative?
Well, I mean, I guess technically if you want to double the a, you can see that you're going to be in a quadrant where a is negative or where 2a is negative. So let's see. Double of 90 is 180. Double of 180 is 360. So between 180 and 360. Oh, okay. Well, I take it back. I take it back. Obviously, this does not help us because in quadrant 4, cosine is positive. But if we were to find 2a, 2a would probably be in quadrant 3. You know what I mean? Like if we were to find angle A, you know what, let's do it. Let's find angle A and let's double it. So let's see. I'm gonna go to Desmos. All right, Desmos. Let's do it. So I said I want to find out an angle. I want to figure out, let's do it in degrees because I think everyone is happy with degrees. So degrees. And can you guys see my screen?
Yes.
All right, so I'm going to go our cosine of, I think I had negative 3/5. So there it is, 126. Was that my initial restriction between 90 or something? I already forgot. Let me see. I'm between, where are you? A is between 90 and 180. Perfect. So there it is. I don't have to do anything to it. There's my angle A. I'm gonna call it A. So I'm gonna go, A is that. A equals. Where's my equal sign? A equals. Okay. So check it out. If I write cosine of 2a, I'm gonna get that answer. What was my answer? Negative 7/25. Let's see what that is in decimal. Negative 7/25. So negative 0.28 is what I better get. So I'm gonna write cosine. And I'm just gonna type 2a in there, miss. 2a. And look at that. Oh my God, it's negative. Yay. And yeah, so we don't really have to worry. The cosine 2a takes care of the positive negative for us. If we were to double that angle, so let me go ahead and see what 2a is. So 2a. 2a is at 253.74 degrees or 7397 degrees. 253 degrees is in quadrant 3. And in quadrant 3, the cosine is negative. But yeah. See, so we verified everything. It works. The math checks out. See how everything just makes sense in math, guys. Everything just it's just beautiful. I really do think it's beautiful. I love this. I can talk math all day, guys. All right, question 14 is exactly the same as question 13. Exactly. The only difference is that guy. When you're doing sine 2a, you don't care about the sign, but you are going to care about the sign when you're doing that one. And so you're going to do everything exactly the same. What's half of 630? What's half of 720? So is it okay if I just have you guys do that one and you guys are good from that? Okay, so let me come back and